guys, happy Thursday! Woohoo! Tomorrow's Friday. Yes. All right. So, on Friday, as you guys know, you are not going to have a science lesson. You are going to answer questions about the videos you've seen Monday through Thursday. So, since it's Thursday, I am going to go through what we have learned about so far in our unit matter, properties, and changes. We began talking about what is matter. And matter is anything that has mass and takes up space. And the smallest part of matter that makes it either a solid, liquid, or gas is a molecule. And so, depending on the placement of the molecules, is going to make it a solid, a liquid, or a gas. A solid, remember, has a definite size and a definite shape. That means that this table is a solid. I can't put this in a small container and it will take the shape of a small container. I can't even put it in a dumpster and it take the shape of a dumpster. It's going to keep its shape. Okay, it's also going to keep its size. And if you look at the way that the molecules are placed, they're very tight. Okay, they're not moving around too much. Less energy than the other states of matter. Then we learned about liquids. And liquids have a definite size but an indefinite shape, meaning that if I had an empty pool and I took a cup of water and put it in the pool, it's not going to take the size of the pool. So it has a definite size, but it will take the shape of the container it's in. And if you look at the molecules in the liquid, they're a little further away and they have more energy than a solid. And then finally we have a gas. And you can see that gases have an indefinite size and an indefinite shape. And you can see in this example here that the molecules have lots of energy and they're not close to each other, which is why we cannot see the gases. I can't see any of the gases in front of me right now, but I know they're there. Okay? And then we avoided the songs. So I'm trying to get to. Then we learned that matter can change. So once something is here on Earth, it's going to stay, but it can change. Those molecules will stay, but they will change. And we can either have a physical change or a chemical change. The difference is, in a physical change, nothing new is produced. Okay? If I were to take this piece of paper and rip it in half, now it's just 2 sheets of paper, but nothing new is produced. It's still the same sheet of paper. And it can generally be undone. I could go to my desk and I could grab the tape and tape it back up and I could fix it. Some examples, anything in the water cycle. Ice melting, ice freezing, water vapor turning to liquid, anything in the water cycle. An example, you can see my hair is a little wet right now. When I came to school this morning, it was very, very wet. And the reason why it's less wet is the water that was on my hair got energy from the heat around me, and it became water vapor. So that's what happened to the water in my hair. Just like when you go to the beach and you get out and you lay out in the sun for a little bit and you get dry and hot again, that's because all of the water on your body turned to water vapor, which is a physical change. Glass breaking, shaping clay. A chemical change, on the other hand, something new is produced that wasn't there before, and it generally cannot be undone. So some examples of a chemical change: decomposition, photosynthesis. Photosynthesis is how plants get their food. They use energy from the sun, water, carbon dioxide, and nutrients from the soil, and once they have those things together, it makes the sugars, it makes the food, makes energy for them. So that wasn't there before. So that is an example of a chemical change. Rusting, ripening. Usually when you cook, it's going to be a chemical change. You can't bake a cake, put it in the oven, and then you bake the cake and you smell it. It smells so good, but you just remembered you needed those eggs for something else and you don't have any eggs left. You can't go back into that cake and get those eggs out. All right, so that would be an example of a chemical change. cannot be undone. It made a cake, it made something new. All right, so some examples of physical or chemical changes. Ask yourself, we have a pencil breaking, the rust on a wrench. I don't know why we have a picture of this cigarette here. Baking a cake, origami, and making a snow, that's a snow angel. All right, so think about, pause this and think, what do you think each one of these are, physical or chemical? Okay, breaking a pencil, physical. Rusting on the wrench, chemical. The cigarette burning is chemical. Baking a cake is chemical. Mixing it could be physical, but baking it would be chemical. Origami, physical. And a snow angel, physical. Cooking a turkey is on the next slide. Roasting marshmallows. Cutting a pumpkin. And breaking wood in half. Okay, what do you think each of those are? This last picture is more rusting, and we just covered that. Go ahead and pause and answer to yourself. Okay? Cooking a turkey. Can you go back and say, oh, I wish it was still the turkey that I saw on the farm? No. So that's a chemical change. Carving a pumpkin, making a jack-o'-lantern, that is going to be a physical change. If you had all the time in the world, you could put all that gunk back in there and fix it back up. Nothing new was produced. Breaking a log in half would be a physical change, and roasting a marshmallow by the campfire is a chemical change. Once you roast that marshmallow and you get it how I like it with all the good brown edges and bubbly, you can't make that be the soft marshmallow that it was in the bag. All right, we'll just do a couple practice questions here. Which best explains why burning leaves is a chemical change? So burning leaves is a chemical change. Why? A, the leaves emit light during the change. B, the shape of the leaves changes. C, the temperature of the leaves increase. Or D, the leaves turn to ashes. The best answer for this would be D, the leaves turn to ashes, because ash is a new substance that wasn't there before. Which best explains why, same question. Tanya observes a mixture of two clear liquids in a container to see if a chemical change occurs. Which observation demonstrates the mixture is undergoing a chemical change? So that means something new is being produced and we cannot undo that. A gas forms after the liquids are mixed. B, the mixture remains at a constant temperature. C, one liquid floats on top of the other. Or D, the mixture does not change color. And this is kind of like the experiment we did yesterday when we mixed the vinegar and the baking soda and it made the balloon blow up because of the gas that was formed. So the correct answer is A gas forms that after the liquids are mixed. So it made a new substance. One liquid floating on top of the other. If you guys have ever put oil and water together, you will see that the oil floats on top of the water. But it didn't make anything new. It's still just oil and just water. So there is nothing new produced. And it could be undone if you had a lot of time on your hands. All right. And the last question we'll do before we take a couple notes is which best describes a chemical change in paper? A, filing paper. B, mailing paper. C, burning paper. Or D, cutting paper in half. All right? And the correct answer there is going to be C. Burning paper would be a chemical change. Once again, it turns the paper into ash. It made a new substance. And you can't, even if you had all the time in the world, you wouldn't be able to, the ash won't go back to paper. All right, I'm just going to go quickly change my screen to note-taking time. All right, and I am going to, what I would like you guys to do is you took notes yesterday. You made that T-chart with your physical and chemical changes. Go ahead and take that out to finish some notes. All right, and I'll be honest, I'll be better, but I do forget which ones we already had on here, so I apologize if I copy. All right, so some examples of physical. This is normally when I would ask the audience, the class, what they would like, me to write up here. And everybody's brains are thinking, so feel free to think of your own as well. All right, so physical. Anything in the water cycle, of course, I do believe we wrote that. So freezing of water, for example. Cutting my hair, if I were to just take some scissors and cut my hair right now, that would be a physical change. Breaking a pencil, breaking a glass, ripping paper. Those are all just making more parts of one thing. You might like Kool-Aid, or maybe you make, for some reason, you need to make sugar water. I think you make sugar water before you put in the Kool-Aid mix or before you make tea. So if you've ever made sugar water before, where you just have the sugar in the water, that's going to be a physical change. Sugar dissolving in water. We saw the picture, origami, when you make things out of paper. That is an example of a physical change. All right, chemical change. Let's add to the list here. We talked about just now in the notes, baking a cake. That may have been on there yesterday, so I apologize. Frying an egg. After you fry that egg, you can't unfry it. So, interestingly enough, cooking an egg is going to be on the chemical side. But if you were to break an egg, that would be physical. Break an egg. Not break a leg, break an egg. Photosynthesis. Let's see. I had something over here. Oh, rotting wood. And once wood starts rotting, it's not going to go back to that nice solid piece of wood that it was before. All right, so just so you guys know, we are going to have a quiz tomorrow. You can watch these videos again. You can use the PowerPoint that is on your Google Classroom to help you find some answers, and you can use your notes. So hopefully you guys will all do great tomorrow, and look forward to what we will be learning next week in science. Bye-bye.